Hello, thank you everyone for joining the 2022 TMACOG Water and Wastewater Operator Training. We're going to allow a few minutes at the beginning of today's webinar to make sure that everyone has time to get connected and to address any technical issues. I'd also like to remind everyone that in order to receive the operator credits, each attendee will be separately registered for this webinar. So we'll give it a couple more minutes before we get started, and then we'll do an overview of some of the housekeeping associated with this webinar, and then we'll get moving on to the presentations that we have scheduled for today. So thank you, and we'll be just a couple more minutes. Hello everyone, now we're going to start with kick off the TMACOG 2022 Water Wastewater Operator Training. The first thing we'd like to do is go through some housekeeping notes so that we make sure that everyone can get attendance and credit for this event. Thank you for attending our operator training for our third year in this web-based format. I'm Matt Kennedy, a water quality planner at TMACOG, and I'm joined by another TMACOG water quality staff member, Sarah Geyer. Sarah will be administering the polls and taking your questions for the speakers. I'd like to give a big thank you to Jones and Henry Engineers for sponsorship once again of this year's webinar series, and to our partners for their time in preparing this valuable training, to our presenters for their time in preparing this valuable training. Today's agenda will include presentations on operational technology, cybersecurity for water distribution and wastewater collection Scada communications by Jim Schultz with HDR, and using real-time sensors to track algal blooms and other source water trends by Ed Verheim with Limnotech. Before we get started, I'll provide a short overview of the webinar format. All attendees will be muted for this webinar. You can use the question function on the side toolbar in order to ask questions to our speakers. That'll be monitored by the TMACOG staff member, so you won't be able to use your microphone, but if you put any questions in the chat box, we'll then relay those to our presenters. You'll be asked to participate in a total of 8 polls throughout this webinar, 4 in each session. It's important that you participate in these polls because they help our presenters get to know you and they count towards your webinar participation score. More on the participation score in a moment. You'll be asked to participate in a survey at the end of the webinar as well. This is also a mandatory component of your participation score. With the polls that we'll be launching, you'll need to complete 3 of the 4 polls in order to receive credit for that participation aspect. And now I'll have Sarah launch a test poll so that you have the opportunity to try it out before the presentation begins. And we'll leave a couple minutes for or just a few seconds for everyone to be able to do that. All right, looks like we've had just about everybody vote. We'll just keep things moving along here. And it looks like the majority of people we have here are operators and administrators, and looking forward to being able to provide these hours for everyone and really get some really interesting presentations we have on a couple of different topics. One of the things that I'd like to mention is that today's webinar has been approved for through Ohio EPA for 1 credit hour of wastewater and drinking water operator contact hours for the first presentation and 1 credit hour for drinking water for the second. To provide contact hours, Ohio EPA requires us to monitor attendance and participation. Now, in order to receive contact hours, you must have the webinar as your active screen for at least 90% of the time during this training event. This means that you cannot use other apps or windows during the webinar. I suggest closing down everything else except for GoToWebinar so that you can make sure that there won't be any issues reaching this participation attentiveness score. Also, you must participate in 3 of the 4 polls, the GoToWebinar polls that come up in each of the presentations. However, your answers will not be graded for accuracy and will not count towards your participation score. Immediately following the webinar and before you log out, you'll be asked to take a mandatory survey. The survey also counts towards your participation score. Any technology issues such as loss of Wi-Fi will not change these participation requirements, and if you lose connection, please try to reconnect as soon as possible. The TMACOG operator contact hour form can be downloaded from the handouts section of the webinar dashboard. And we'll also be sending out a reminder about an hour after the webinar about getting those forms back into TMACOG today. Now, I will go ahead and pause my screen. Today's webinar will include 2 presentations with a 5-minute break in between those presentations. During the break, please do not log out of the webinar. With those announcements out of the way, I'd like to introduce our first speaker. James Schultz is a cybersecurity network engineer at HDR with 30+ years of experience with control system engineering and information technology experience in the water, wastewater, manufacturing, and electric industries. He has experience in cybersecurity industrial network design, control system engineering, master planning, data modeling, database development, and application development. He's a registered professional engineer and holds several certifications, including Certified Information Systems Security Professional, Cisco Certified Network Associate, Certified Ethical Hacker, Global Industrial Cybersecurity Professional, and Certified Information Systems Auditor. And with that, I will turn over the event to Jim, and he can start with his presentation. Thank you.
All right, very good. Can everybody see my PowerPoint presentation?
Yes, we can see it.
Okay, very good. Let's see here. I'm just going to try to move this out of the way. All right, so the title of today's presentation is Operational Technology Cybersecurity for Water Distribution and Wastewater Collection, Scada Communications. As Matt said, I'm trying to take control here. As Matt said, my name is Jim Schultz. I'm a cybersecurity network engineer for HDR out of the Philadelphia area. And this presentation is going to have 5 parts. There'll be a brief introduction, followed by operational technology for SCADA communications. That's the main part of the presentation. Because this is all about training, I will provide some additional resources in case you're interested in learning more about cybersecurity in the form of guidelines, standards, training, and alert services. And then the last section will be about questions and answers, in case you have any. So just to start off, I want to get everybody off on the right foot with terms you're going to hear quite a bit during this presentation. So IT means information technology. I think most folks know what that's about. At risk of greatly oversimplifying it, I think of IT as the systems that you use to access the internet on a regular basis, email, to do your timesheets, access HR, cut purchase orders for equipment and whatnot. Its counterpart, operational technology, is very much about industrial automation and critical infrastructure. So operational technology can be broken down even further by PCS, which I call process control systems, and that would be all of the technology for running your water and wastewater treatment processes inside the fence. Okay, Scada is everything outside the fence. So in the case of water, that would be elevated tanks and booster stations. For wastewater, would be lift stations and perhaps CSOs, just as a couple of examples. So when you hear these terms, that's what I'm referring to. All right, so on to the second section, which is the main part of the presentation, operational technology for SCADA communications. So here is a big picture overview. And what I'm showing you right now is the way networks are connected together. So way over on the left, we have the internet. We have an IT DMZ, which kind of protects the IT network from the internet. We have an OT DMZ, which connects the IT network and the OT network together. And that OT DMZ protects both of those networks. The SCADA DMZ sits between the OT network and the wide area network for collecting SCADA data. And that SCADA DMZ protects both of those networks. And then way off to the right, we have all the remote sites. Okay, so this applies equally to both water and wastewater. It also applies to water, electric, oil, and gas. Okay, so once you get away from the pipes and the process, a lot of the technology solutions start to look the same, which is kind of good news in terms of cybersecurity, because you don't have to develop new solutions for every type of system that's out there. We can develop standards and reuse them, and develop a workforce that's familiar with those standards and can help out in various situations. So what we're looking at here is what we call the Purdue Model. And this is something that's very popular in terms of connecting IT and OT networks together. This is a standard, the conventional wisdom on how to do it. And it's been adopted by ISA 62443, which is an international standard for how to connect IT and OT networks together securely, as well as a whole bunch of other things. So what really characterizes the Purdue model are these couple of terms, zones and conduits. And zones are what they refer to as networks, okay? And conduits are devices that sit between networks and can filter traffic. That's a huge part of what we do in cybersecurity. Is we try not to let networks just talk to each other any old way they want. We try to restrict it to just the minimum needed to meet business needs. And that's what we're going to talk about today. Is the more like the OT side of things with your plant process control, your remote site communication network, or let's just call it a wide area network for now, and then the remote sites. And you can see here we got these red firewalls. I'm giving you a little bit of a sneak peek as to what I'm going to be talking about in this presentation. There's going to be a whole lot of talk about firewalls. In fact, I'd say that would be 90% of what we're going to talk about. And how they can be used and how they can be leveraged to secure your networks. So if you notice over here, we have this blue circle. That is going to remain constant through like the next 5, 6, 7 slides. And I'm going to add different content. We're going to add some routers, we're going to add firewalls, and we'll talk about what that gets you. So without any further ado, I'm going to move on to the first slide here. So you can see here we have this wide area network again, and what we're showing here is just routers around the outside, 1 at the main site and then 4 at the remote sites. And this wide area network can be made up of a lot of different solutions. Okay, you could have the wide area network based on the internet. Now that would be the worst possible scenario because all of your data transmission would be transmitted in the clear. That means potentially passwords and usernames could be sniffed, if you will, and then later used for to gain access using those usernames and passwords. Okay, we're going to go from less secure solutions to more secure solutions down at the bottom. So next up we have licensed radio. There, you see sometimes 400 megahertz, 900 megahertz for licensed radio. Next up we have unlicensed spread spectrum radio, and this is more in the industrial, scientific, and medical band, which is kind of what many people use. It's public domain access. It's at 900 megahertz and 6 gigahertz are very popular for Scada. Next we have cellular, which includes 3G, 4G, and 5G now. You can also have a cellular private network where only you and people in your organization with proper permissions can access the address space in that private network. So it's a little bit more secure than cellular. You can have microwave point-to-point. Okay, so if you have 2 plants and you want to have one back up the other in terms of your human machine interface, you could have a microwave point-to-point connection with a very high-speed connection. Next up, we have provider services that you might get from Verizon or AT&T, and Metro E and MPLS are way beyond the scope of what we want to talk about, but just listing them here for example purposes. You can lease fiber, okay, and you can install private fiber if you want to dig up roads and install fiber for your own purposes. Maybe you're putting in some pipeline and you run fiber next to the pipeline and you're going to leverage that for your system. So these are all, not all of them, but I would say most of the popular solutions that can plug right into that wide area network. And we can see that some solutions are more secure than others, okay? We take it one step further, we can add in the OT network and the remote sites. And again, these blue boxes on the wide area network, they're just routers, okay? And a router's job is to take a request from, say, this network that needs to talk to another network over here and say, yeah, I know exactly what to do with that. And it routes it along to the proper destination, okay? And with routers, everything can talk to everything, unrestricted. That is their job. By default, everything can talk, okay? So if you have a data acquisition server, say this green box here wants to pull tank level information from this PLC, it can do that through potentially 65,000 plus TCP ports and 65,000 plus UDP ports for a total of 130,000 plus ports. Think of ports as like ears and mouths, okay, that devices can use to talk to each other. Well, that is the absolute worst case scenario, because what we want to do with cyber, to a very large extent, is take that 130,000 plus possibilities and get it down to 5, 6 ports. So you could see that, we want to try to restrict traffic between networks. So some of the possible attacks you can have with all these different systems, and they vary depending upon that graphic we just saw yesterday with the internet at the top and then private fiber way at the bottom. So some possible attacks are denial of service. Okay, if you have a radio system and that frequency that you're communicating on is part of the FCC website, someone could probably figure out how to jam that frequency and create a denial of service. If someone's able to listen in on your network, they could record traffic and then later replay it. Okay, and if that traffic was used to shut down a pump, that same command could shut down a pump at the wrong time. You can have spoofing where there's a fourth supposed remote site that someone is pretending to be, and that's what spoofing is, someone pretending to be a legitimate endpoint. Okay, you can have man-in-the-middle attacks with a whole wide variety of scenarios with DNS and ARP cache poisoning. There's a lot of different attacks like that where someone could, if they have access to this network or even the remote site network, pretend to be somebody else, insert themselves in the middle of your traffic, get traffic from one point and then transmit it to the other and act as a man in the middle. You can have reconnaissance where people are recording information and gathering it for a later attack. And you could have just plain eavesdropping, which isn't the worst type of attack. And if you're going to get attacked, you'd probably rather that more than anything else. It's just someone listening in on what's going on. But there's ways to greatly reduce the possibility of all that. So this is what an unprotected Scada network looks like. Everything can talk to everything because we're using routers, and that's what they do. They allow traffic by default. Okay. Now, if we start adding in firewalls, like I said, we can do a whole bunch of things. Now, firewalls, as you can see at the top here in green, they help to restrict and minimize traffic to just what's needed in order to meet business requirements. So on the previous screen, the data acquisition server and the PLC could talk to each other potentially through 130,000 plus ports. Now, that's not what would happen all the time, okay? If you have maybe 25 to 50, maximum of 100 ports open and being used, that would be a lot. But still, we want to get that way, way down. So we put firewalls in, and that helps us to restrict that traffic. Okay, and one of the nicest things about putting firewalls in it allows Ipsec Vpn tunnels, and when that happens, all of the traffic, and that would be these green dashed lines off to the right in the wide area network area, all the traffic that goes from the Scada DMZ to the remote sites is encrypted. And the latest encryption is 256-bit AES. It's considered virtually undecipherable. And the other benefit of the VPN tunnels is that these remote sites are authenticated, so that prevents spoofing. So that the firewall can say, hey, I want to make a VPN connection with you, remote site. Here's my credentials that proves who I am. And then the remote site can accept the connection. And the other thing about these site-to-site IPsec tunnels is that they're permanent. So it's a little different than when you're dialing into work from home using, say, SSL-based VPN software. Okay, so these are permanent. Once they're established, you don't have to reestablish them unless you take it down, for example. So this is probably the best benefit of firewalls, is getting these site-to-site IPsec VPN tunnels. So the other thing that you might notice here is that that data acquisition server that was on the OT network is now in a Scada DMZ. So the reason we do that is that we don't want direct communication between the OT network and the wide area network. We want all traffic to terminate in that Scada DMZ. And that's a very important cybersecurity concept. Okay, and that data acquisition server in this case is considered what we call an intermediate system, quote unquote. And the other nice thing about firewalls is that it allows the analysis of traffic in order to detect intrusion and also to prevent intrusion. So the firewall has a list of signature-based detection scheme. So it can look for a certain kind of traffic, and when certain conditions are met, it can send an alert to somebody on the OT network to say, hey, something's going on here you should be aware of. You might want to take a look. So that's more of a passive approach. The more aggressive approach is intrusion prevention, where it says, I'm detecting a signature that looks funny to me, therefore I'm going to shut down the communications. So that's a risk-based decision, because if it makes a mistake, you could shut down communications to a booster pump station or a tank, which you would not want. The other type of system is anomaly based, where the system's allowed to run for a couple of weeks. It kind of learns what normal traffic looks like, and then after you turn it on, it will alert or shut down based on a deviation from what it thinks is normal. Okay, and that could be more risky, but it also helps with detecting new attacks. So this is what we would consider a protected SCADA communication system, with the addition of these firewalls and the addition of that SCADA DMZ. We've got even more. So if we use firewalls, we can use rules to limit traffic to the minimum needed for monitoring and control. So we would do that by starting off with all firewalls having a denied all traffic by default policy. So that means nothing can talk to anything else. And we would allow exceptions based on analysis and approval. So for example, we might say this data acquisition server can use Modbus TCP in order to communicate with this PLC over here. And we would open up that port on this firewall and this firewall. Okay. Now we've minimized traffic and the ability to communicate for these remote sites to just what's needed. Now, Modbus is not a secure communication protocol. It transmits everything in the clear. There's no authentication. There's a lot that can be leveraged on that. However, we are going through encrypted VPN tunnels, which is a countermeasure that makes that insecure protocol much more secure. All right, so we can also control the direction of traffic. So what we would not want is for the remote sites to say, hey, I got a high level, and then initiate communications into this firewall, because that means we have to open up a port outside of the firewall to let traffic in. What we want to do is make sure this is like Fort Knox and nobody on the outside can get in. So what we can do is say all traffic will be initiated, will be allowed out of the firewall so that it can request information from the PLC, and then the PLC can respond. Okay. So some protocols like DNP3 are very, very efficient. And when something changes, it communicates to the central site. That's great. It's not great for cybersecurity though. So what we could do with that protocol is say, we're gonna pull for exceptions. So we're gonna have this server say, hey, site one, do you have anything that changed? And it may say, nope, go to the next one. So it goes to the next site. Site two, do you have anything that changed? Yes, I have some things that changed. Here it is. And it would respond back. So that's one way around the report by exception capabilities of some communication protocols. And last, we have no remote to remote communication. So, back in the old days when networking started, the mindset was, oh, wow, this is great. Every computer and every device on the network can talk to every other device, and we only need one printer. Isn't this wonderful? And then hacking started, and the mindset quickly became, oh no, everything can talk to everything else. How are we going to stop this? And that's where firewalls were introduced. So you don't want remote to remote communications unless it's needed. So some exceptions could be, booster station talking to an elevated tank in order to fill the tank back up as needed. For a wastewater example, you may have a level sensor upstream from, say, inflatable dams to give it some advanced warning so that you can inflate the dams ahead of a large increase in flow, going to the plant. So those are some cases where you would want to allow the site-to-site communications. So some other firewall benefits is you can get routing capability that allows for backup communications to critical sites. So off to the right, you can see I've added a little bit of blue lines, and let's just say you have like your entire network is radio based and you have one site that's really important. Well, you could put in cellular modems, okay, and have that complement your radio network. And routers do an excellent job of dealing with a wide variety of communication mediums. So you could conceivably be using all of those solutions that we had on that first slide. And the router is going to very dutifully keep a list of all the possible routes, from one point to another. And it's going to use the most efficient and fastest connection typically. So if it's a cell modem that has a 50 meg connection and your radio system has a 1 meg connection, it's going to lean on the cellular connection until it fails, and then it's going to fail over to the radio. So routers do a phenomenal job with that type of problem. If you look at this Scada DMZ, you might say, wow, there's only one firewall there. That looks like a single point of failure to me. And that's true. If you lost that firewall, you would lose all your communication out to the remote sites. So what you can do is put in 2 firewalls there and then set them up in a high availability pair so that if the power supply on one fails, the other one is just sitting there ready to take over. In which case, you have time to fix the other one and you wouldn't lose any communications whatsoever. Another cool thing you can do is look at deep packet inspection. So a lot of these protocols, the 130,000 plus possibilities, a lot of them have vulnerabilities where you can misuse the protocol, like DNS and HTTP. You can tunnel through them, and you can take advantage of vulnerabilities in them so that you can create these malformed packets and do all kinds of damage. So deep packet inspection allows you to look for that sort of thing, and when you see it, you can stop it, or it can alert a technology person to take a closer look. One thing that we all use every day without probably even realizing is stateful packet inspection. And in this particular case, the Scada DMZ, the data acquisition server would say, hey, PLC, I need to know tank level, all right? So it would initiate communications out through this firewall. The firewall will keep track of that request, okay? You go over to the PLC, and then the PLC would respond, and then this firewall says, okay, that's the traffic I was expecting in return. I'm going to just let it come right through. And that's as opposed to letting just any traffic into this firewall that we want to be like Fort Knox. So that's what SPI does. It keeps track of the communication going out. When it sees a response coming in that matches, it just lets it through. And that makes this, a very secure solution. And last but not least, we have different products out there that are all in one. It can be a firewall, a router, and a switch for just connecting devices on a local area network. And they're all fancy terms for just networking appliances, but the whole idea here is that they can be very simple for your remote sites. So that's pretty much what we have for firewalls, and I'm hoping that if we have any engineers on the line that you're listening and considering putting these in for your next Scada design, if we have operators out there and administrators, and you have a new system going in and you're participating in design meetings, that you see some of this, and at your next meeting you may say, hey, are you going to put firewalls in? Something to that effect, where you can kind of collaborate and just be a better contributor to meetings like that. Okay, so some other good ideas for Scada communications are defense in depth. So cybersecurity controls can be circumvented in many cases. So what we want is to have a variety of controls backing each other up in case one fails. So the most simple example I can think of for defense in depth is my dog. Okay, we have a door going to the garage, and we have the garage door that goes up and down. As long as both doors or one of them is closed, the dog can't get out. So if one fails, meaning someone left it open, I don't have to worry about that problem. because my dog is fast enough where I'm never going to catch the dog, and it will be a problem, as it has been in the past. So that's defense in depth, where one control is backing up another control. So network segmentation is something we learned quite a bit about with the Target hack that happened a long time ago, and that was one where hackers reached the point of sale machines through an interface that the HVAC contractor used to get in and make adjustments to the HVAC system. They just had one big giant flat network, and as soon as the hackers got in, they accessed all the credit cards on the point of sale registers. So network segmentation is absolutely huge in cybersecurity. So if we count the circles here, the networks, we have 1, 2, 3, 4, 5, 6, 7 different networks. Okay, I have seen systems just like this one that were all one big network, and that is a nightmare to try to defend, because firewalls don't work at that level, and you are opening up the possibility of all sites being able to talk to all sites through any communication protocol. And that's exactly what we started off saying was a nightmare. So another thing you want to try to avoid is having any backdoors into your system. We call that perimeter protection. So if you look at that HMI box right in the middle, maybe you have Win 911 running at your plant, and you have a cellular modem connected right to that HMI to get you text alerts on your phone. That's exactly what we're talking about not doing, having a backdoor from an external network right into your OT network, okay? So the better way to do that would be to go through the the OT DMZ that we saw originally and push that information and that message out that way. And it will get to you. There's a variety of solutions to help you with that. As far as ransomware goes, you hear about that just about every day. Your two best approaches for avoiding ransomware are patching and backups. So patching, I'm sure we're all familiar with. That's when on Tuesday you go to do something important on your computer and it decides it wants to update the whole operating system, and your machine slows down and Microsoft pushes updates to your laptop. Well, that's what we're talking about to a large extent. You can also patch firewalls, routers, switches, servers, operating systems. If you have PLCs and flow meters that have firmware, all of that, it's microprocessor based. The firmware can be patched and updated. So generally speaking, we'd say it's easier to keep up than it is to catch up. Okay, and you want to test patching offline, because every control systems engineer has a story about the patch that didn't go well and it took down a live system. So you want to test it offline and make sure it's going to be good for your production environment. Backups are your next best solution to ransomware. So you want to make sure you're testing them to make sure that they're viable, and you want to keep them for a long time. So you might have heard of SolarWinds, and SolarWinds attack, that was an advanced persistent threat purported to be Russia on our federal networks for 6 to 9 months undetected. Okay, and that's what we call an advanced persistent threat. If their intentions are other than stealing intellectual property and they want to really do harm, first thing they're going to do is they're going to cripple your backups, and you may not know about it. So you want to keep them for a long period of time, so that if the most recent one doesn't work, you can go back to the one before that and at least recover some information. So I had a discussion with a Scada manager at a plant that I was working at, and we were talking about cybersecurity, and he said, I just can't imagine the amount of time and money it would take to redo everything from scratch if I lost everything. So he was a guy that really understood the importance of having good backups and making sure that they worked and keeping them for a while. Some other good ideas, least functionality. So I don't know if you bought a laptop recently. I did, and it had all kinds of stuff on it that I didn't need, like Xbox and tablet mode and all these other different kinds of things. So first thing I did was I got rid of all that. And the less you have running, the smaller your attack surface is, because all those ports I was telling you about, the 130,000 plus, they're turned on by software. And when software wants to talk to software, it goes through hardware to do it, and it uses ports. So if you uninstall software, you're reducing the number of live and active ports that are either communicating or waiting for something to communicate to it. And that's called least functionality and hardening. You also want to do least privilege. So users on your network have just the amount of permissions that they need to get their job done and nothing more. Okay. And last but not least, cybersecurity requires good physical protection. So if an attacker were to gain access to a remote site, say they have a bolt cutter and they picked the lock on the front door and they walked in and plugged right into the switch in a panel, they could wreak havoc. All right. So if we have firewalls, that will help to limit that damage because there's only so much they can do in order to get through it. However, they could always disconnect the firewall and plug right into the router. But because you have other firewalls, you're still limited to what they can do. So anyway, good physical protection is an essential prerequisite for cybersecurity. All right, so it's time for poll question 1. So I can't see the poll question. Is it being displayed now?
Can other people see it? Or I guess, Matt, can you see it?
Yes, it's everyone but the presenter can see it.
Oh,
Okay,
okay.
what is the question?
The question is, a well-configured firewall, and select one, either restricts traffic flow only to meet business needs, or all network endpoints can talk to any other network endpoint.
Gotcha.
All right. And it looks like we have everyone. I think we have everyone aside from the panelists and Matt and I. I can go ahead and close that. Okay, we had 94% of respondents say that it was answer 1, which is restricts traffic flow only to meet business needs.
All right, we got good listeners out there. That's the right answer. That is I would say, one of the main points to take away from this presentation. All right, so on to the next section, which is popular guidelines and standards. Now, I imagine we probably have a mix of folks out there. I've certainly known plenty of operators that have jumped in and helped out with the programming of their Scada system or plant process control system. I've certainly been a part of plenty of presentations where we have engineers and administrators in the audience. In keeping with the theme of education, I want to point out that there is a number of guidelines out there that you can and should look at if you want to learn more about OT cybersecurity. So one of them is from DHS and ICS CERT, and this is improving industrial control system cybersecurity with defense in-depth strategies. Okay, what you see off to the right here is an adaptation of the Purdue model. Okay, so we're showing, if you remember the first graphic I showed you, this is kind of rotated 90 degrees. So we have the OT network basically up on top, and then all the remote sites down at the bottom. And this is a very readable 58 pages, as opposed to some other documents like NIST 853 and NIST 882, which are hundreds and hundreds of pages. So it's a very good high-level introduction. If you want to use this Purdue model in a presentation, you can do it because our tax dollars paid for it, and there's no copyright protection on using this information, which is why I'm using it now. And it wasn't free, but it's free to download. All right, so this is from 2016, and the concepts in it are still very applicable. More in line with engineering, we have ISA 62443. Again, this is an internationally recognized standard for OT cybersecurity. I'd say this is probably where the Purdue model was first introduced. It's $130 per year for membership, at least it was last time I joined. And you can see that there's 7 standards that are available now. I know that they're working on and maybe 1 or 2 more since I originally created this slide, but there's more on the way. This is a behemoth of a resource to go look at and to try to read. So I wouldn't start here, but I would definitely be aware that this has very, very good information, especially from an engineering standpoint. So those are 2 things. I have normally others, but I wanted to just focus on those 2 because I think we're probably going to have mostly operators in the audience today. So if you're interested, go check out these resources. And that brings us to our next poll question. And if you wouldn't mind reading that poll question to me.
Sorry, I clicked on the wrong thing and everything disappeared. Okay. So this question is, there are generally accepted best practices available to help solve a wide variety of OT cybersecurity issues. So this is a true or false. Last time it took just over a minute, so we'll probably wait about 20 more seconds to let the last few.
Okay.
All right, go ahead and close that. And then 100% of people who answered said that that was true.
All right, great answer. Appreciate the good listening, everybody. And it's true, there's a lot of generally accepted best practices available to help solve OT cyber solutions. So it's not just for water and wastewater. There's a lot of effort being put into developing standards that can be leveraged across multiple industries. You don't have to go solving the problem. You can just leverage what's already been solved and apply it. So that's the good news. I'm not sure the last time you heard good news used in the same sentence as cybersecurity, but there you go, maybe a first. Okay, so on to the next section, which is free training and alert services. So again, we're keeping with the theme of training and learning. And if you are interested in cybersecurity, there's some just phenomenal resources out there that you can use to learn. So what I'm showing here is, I think there's 13 different classes from Idaho National Labs. All you need to do is sign up. So you got to give them your name and some modicum of information. And then you can sit through and watch all these different videos and go through these classes, okay? All online at your own pace for free. The other alternative, and I'm not sure if they've started this back up after COVID, but they do have very similar training that you can go and attend in person. It's a week long, and the training is free. The tuition, that is, you have to pay for your travel expenses, but the training is free. So if you're interested in learning more, you can go to the Idaho National Labs website, and assuming that they've started this up, now that COVID has died down, relatively speaking, you can sign up for that training and attend. So as far as intelligence sources, I get all of these different sources here. ICS CERT advisories, they're free. US CERT advisories, they're free. MS-ISAC, information sharing and access center advisories for free. InfraGard, which is associated with the FBI. It is not the FBI, but they are affiliated. That's free, but you must apply and provide some personal information to get that. So these are all free. Okay, I get them. I think the one at the bottom, Water ISAC, is my favorite because I think that it allows for the best balance between detail and things you need to know. All right. So those are some alert services, and now we're on to poll question 3. And if you wouldn't mind reading that to me.
Okay, this one's another true or false, and it is: there is an enormous amount of free download material available to learn more about OT cybersecurity. So true or false? All right, it looks like we have everyone responded. So and 100% said that was true.
All right, great listening. In addition to the resources I gave you, I've accumulated a library of PDFs, and they come from NIST, National Institute of Standards and Technology, CISA, Cyber Infrastructure Security Administration, all different kinds of resources. If you just go out and search for critical infrastructure, cybersecurity, ICS, industrial control systems, cybersecurity, you're just going to come across an absolutely enormous amount of material that you can download and read at your own pace in order to learn more about cyber. I would say start with the Idaho National Labs, but certainly there's just a ton more that you can get, and you will have ample reading material for many years. So that's pretty much what I have for the presentation. So I'm hoping folks have some questions that I can help answer.
Yeah, and Jim, I think we'll go ahead and also launch the 4th poll question, just to kind of help guide some conversation here. So Sarah,
Okay.
if you want to go ahead and launch that next one.
Sorry, I had to pull up the right one. Okay. So this one is: how often do you receive general cybersecurity awareness training? And the options are never, about every year, less often than every year.
And I really wanted to make sure we also got to this one because it seems like we're getting a lot of very diverse answers in, and it seems to be really, I'm sure you'll see when we post this that it's a little all over the place, and there doesn't seem to be a whole lot of standardization on how often people are able and aware, to be able to get these kinds of trainings.
Okay.
Yeah, so out of those who responded, we have 41% who said they never receive general training. 29% have some training about every year, and then another 29% have less often than every year.
Okay. So this is a very, very important cybersecurity control, actually, just user awareness. So it just takes one click on your IT network laptop, the one you use for the internet and doing timesheets and checking email. If you just click on one bad link in an email, that's enough to ruin your whole day, because that can install software on your IT laptop or desktop, which can go undetected and then be used by a remote hacker in order to launch an attack against the OT network. So this is not an uncommon theme. So there's a few resources out there that are available, like KnowBe4. That's the name of a company that I've heard people use that have very good user awareness training, and it's either free or it's very reasonably priced. So you should strongly consider that. You know, we always say, you know, that the user is the weak link in this whole process, and unfortunately that is true, because you know, that one click on an email could install malware. It could also install ransomware. That's a very, very popular vector for ransomware. So just keep that in mind, and try to, if you're not getting that training through work, try to find something on your own time in order to, you know, make yourself a more secure employee. So that's what I have, Matt. So I think we have time for questions.
Yep, so I'll remind everyone that you can put in any questions that you have into the chat box on the GoToWebinar dashboard, and then TMACOG staff can read them out. I know one of the questions I have is, have you seen more adoption of these types of security protocols over the past couple of years? Is this something that you're seeing, I guess, positive advancement for, of people adopting these types of more secure technologies?
Absolutely. So we're getting more and more stories in the news that I think are raising awareness of the problem, and I think more people, you know, especially executive directors, you know, they are accountable for what happens with these systems. So there's a lot of interest at the corporate level to make sure that you know, these cybersecurity controls that we're talking about here are getting implemented. There's, of course, we have the America Water Infrastructure Act, which requires everyone, all water utilities of a certain size, to perform a vulnerability assessment. And that has also raised a lot of awareness as to, hey, you know, where do we stand in terms of cybersecurity? And it provides a whole lot of food for thought on things that you could be doing better. And we do see people adopting a lot of these controls to strengthen their networks.
Another question I'd have would be, what's kind of the time frame that it takes? So say you have one of these organizations that doesn't really have as much security as, you know, maybe they identified some issues. Kind of how long does it take to get one of these more secure systems up and running and functioning?
Well, that can take some time. So I always think of the 80-20 rule. You're going to get probably 80% of your benefit from 20% of the solutions. And the other thing I like to say is that cybersecurity is risk management. So you're not going to be able to do everything, probably, because you're not going to have enough money to do it. Even if you did, you'd still have to start somewhere, because some resources are more important than others. Some are more critical than others. So you need to do some sort of risk assessment in order to determine what those really essential assets are, so that you can start and address them. So we typically recommend a phased approach, where you get that OT DMZ between the IT network and the OT network, because you definitely want to keep them isolated. You don't want IT and OT sharing the same space. That's just a recipe for disaster. So start with that DMZ, you know, and then start to build on that infrastructure that you put in. So if you need to have remote access, you can put a pivot point in that DMZ and use that for remote access. If you really want to have access to HMI read-only graphic screens, you can put a web portal in that OTDMZ and access graphics from the IT network on a tablet. This way you're not constrained to the control room. And that would be read-only, so you don't have to worry about someone taking control of your system. So we recommend a phased approach. You know, what I just described, putting in that OTDMZ, that's something that you could definitely do within, you know, say a 9-month period. And a lot of times your Scada technicians have the capability and the knowledge of how a firewall works to be able to put something like that in for you.
Great, thank you. Do you have are there any particular, I guess what I'd say, success stories that you'd be able to highlight of something where, not necessarily a particular organization or location, but what would you say was a very, successful outcome that you've kind of seen recently?
Okay, so my company did a project for a large wastewater utility in the Midwest, and we went in. They were very much interested in cybersecurity. They were very good at it. So we made some recommendations as to what could be done to bolster things a little bit, and they took all the recommendations and implemented them. One of them was segmentation. So they had a very large network, and we implemented different VLANs so that, again, everything couldn't just talk to everything. They had to go through a firewall in order to be able to communicate with another network on the OT side of things. Okay, so that OT network was broken down into smaller segments. And that was one where there was a recognition of the problem. We proposed some solutions that they liked and they went with, they implemented them, and their system is more secure as a result.
That's good to hear. Do you notice particular issues? I would assume, once you get to an economy of scale, we've kind of got a pretty wide range of smaller plants to much larger ones. Is there anything that you see, any particular challenges for either smaller plants or larger plants?
Well, the smaller plants definitely have fewer resources. Just the staffing is less, and you find people wearing multiple hats. You might have an operator doing the HMI configuration, but they also have operations that do it at the same time. So they're getting pulled in different directions. And I would say that the smaller plants have maybe more challenging financial resource capability compared to some of the larger plants that can get some of this on their capital plan and fund it a little easier.
Another question I'd have is, kind of the converse that where we talked about earlier, some of the successes. Have you come across issues, or how have you resolved potential problems related to kind of resistance potentially to being able to implement these problems? Is that something that you've had to come up against and really had to work uphill to convince people that this needed to be done?
Oh, absolutely. So sometimes we say that the biggest problem is people don't think there's a problem. And that's the way it goes until they get hacked, and then they tend to see the wisdom in it. So there's some convincing sometimes, and the bottom line is that if people don't want to be helped, then you're not going to be able to do a whole lot to help them. And if they want to be helped, then there's a lot you can do. We always try to share stories and explain the why behind recommendations we make, so that folks can really appreciate the gravity of it all. Certainly, you look at solar winds, and that was a huge problem. Russia purportedly on our federal networks for 6 to 9 months undetected. We had attacks in Florida, Kansas City, California. So it's a definite issue. And of course we have the Colonial Pipeline, and that one was interesting because it was an attack on IT, ransomware, but out of an abundance of caution, they shut down all of the OT. And that can happen at any point in the future. An attack on IT could shut down OT for the exact same reason. And we all know what happened with the Colonial Pipeline. A lot of us were put out, and it was difficult to get gas. And it really made you wonder, how secure are we? How good is our electric grid? Without electricity, you're not going to be doing very much. You're not going to be pumping water. You're not going to be collecting wastewater, that's for sure, unless you have some really good backup power and generators. So we do our best to try to explain the risk, and I look at it like, this is risk-based management, and kind of like your 401k. If you're an aggressive gambler, maybe you have everything in the stock market. If you're more conservative, maybe you do like a 60-40 mix of stocks and bonds. Okay, this is all based on your personal risk tolerance, and cybersecurity is very much like personal risk tolerance. One utility may have a high tolerance for risk and not feel like it's worth putting the money into, and another may have a low tolerance for risk and ask for a lot more help in terms of solutions. So yeah, we definitely run into that.
And kind of coming up on that, so say they're, worst case scenario, and an attack occurs on a plant, and for whatever reason they would, may lead to them having to shut down operations or something like that. They're not able to continue. Is there, I guess I would say, how long would it take for something like that to come back online? Or is it very much based on what the type of attack would be and kind of where the vulnerability came from?
It very much would depend on that, and also the size of the system. So two things I think about with that is, how well do the operations staff know how to run the plant in manual, or the collection system or distribution system in manual? Because we rely so much on automation that a lot of times that part of your brain doesn't get exercised. So that's one concern. Number two is, automation is often used as a mean to downsize staff. So if you were to get hacked, and the technology folks were frantically trying to bring things back online, you'd have to run in manual, so you'd have to know how to do that. But then how many staff do you have to cover 3 shifts, and how long are they going to be able to do that? Are they going to be able to do it for a week, a month? So these are some things to consider. I've seen utilities that they have manual day. So 1 day a month, they run everything in manual without the PLCs and the HMIs, and they test their ability to keep things running, on a real skeleton type system.
Great, and I think one last question I would say is, how often do you see these kinds of attacks happening? Because I know we've talked about risk management. Have you seen increases in these types of attacks coming through in recent years, even on the small scale?
So a lot of the information we get is through those information sharing resources, the ISACs, if you will. So we get email alerts pertaining to attacks on electric, oil, gas, water, wastewater. Certainly once you start introducing monetary motivations like ransomware, things are going to pick up. And because the critical infrastructure part of things is so important, to delivering water, delivering electricity, they've become a real target. They're harder to get to because a lot of people are protecting their systems, and not everything is just hanging out on the internet. And we would never, recommend that. That's another worst case scenario. But if someone can get in because someone clicked on a bad link in an email, and they can, move laterally through the system in order to get to the OT network to install ransomware, the utility's probably going to pay it, because, like I said, with that one resource I was working with, they estimated, it would take years to recover the system to start over from scratch. So yeah, we definitely see an uptick in terms of ransomware with critical infrastructure based on the news that we're receiving. I think a lot of attacks don't make the front page. They go unreported just because there is a certain kind of embarrassment factor. You don't want people to know. One of the things that the government is doing now is requiring oil and gas and electric for quite a while now to report incidents. You have to report every single incident. And that's just so we can develop an understanding of, what's going on today, what are emerging attacks, who do we have to watch out for. So that is something very recent within the last year or so that the government has required of oil and gas.
Great. Well, thank you so much for taking the time to give this fantastic presentation. I know this is So you can see it's quite a mix of when people can actually hear about these types of topics, and we really appreciate you coming by to be able to talk about that.
Oh, I'm very happy to do that. I appreciate everybody's time and willingness to listen.
Great, thank you. So now everyone will take a 5-minute break before we go to our next presentation. So what I'd like to mention is that everyone, if you could keep up the webinar so that you don't lose access to that participation score. So just leave up the webinar, we'll take a 5-minute break, and we'll reconvene at 1:17 for our next presentation. Thank you. All right, thank you everyone. And now to move on to our second presentation, we have Ed Verheim is a principal engineer with Limnotech and president of the Freeboard Technology. Since joining Limnotech in 2005, Ed has been involved in dozens of Great Lakes and other large lake projects that push the limits of technology and innovative research and development. He oversees a network of buoys and sensors that support boaters, water treatment plant personnel, and many others. In 2022, Ed worked with Limnotech to found Freeboard Technology to advance the use of emerging technology. Ed has also served as the president of the International Association of Great Lakes Research. And with that, I'll hand it off to Ed for his presentation. There you go.
You see my screen okay?
Yes.
All right. Thanks, and that was a really good last presentation. I think I've been deploying a lot of buoys and instruments on Lake Erie over the last few years, and so it's good to kind of see how, you know, this sort of plant firewall and all the data moves. So I'll be mostly talking about assets that are outside the bounds of those networks and generally stream data to the internet. And I think this is kind of where this some of the delineations pick up between our monitoring of source water, you know, sort of the source water monitoring programs. So today I want to just give everyone a little bit of a historical overview on it's, you know, kind of how we started doing this and some of the advancements along the way, some of the lessons learned. I think for me, my background is environmental engineering, so sort of seeing what you're taught in school and how the importance of this transition of new material, new understanding actually makes its way into the knowledge base of the facilities has been a really great process to see. You know, we really couldn't update textbooks fast enough for how we understand how these environmental conditions impact source water and how water treatment plants can start, you know, seeing those dynamic lake signals and knowing how to add chemicals. You know, I don't see this interest in monitoring source waters going away. It's you know, I know folks have talked about you know, ozone as being this magic, whatever's in the water, we can zap it. And, you know, I think we want to watch any statements like that, because I know we all said some of those same absolutism statements in previous years. So again, I think the environment is constantly changing. We're also changing what we understand about impact on human health. Just to focus just a tiny bit on harmful algal blooms here, I just grabbed this graphic, and I've certainly, you know, my work involves studying harmful algal blooms and impacts on lake, and it's really tough for me to assess, is the problem getting worse, or am I just getting better at talking about it? And this graphic here attempts to compile news reports. You know, there isn't a sort of formal CIA or anything that's going out and scouring every water body every year to understand if there's a harmful algal bloom there. So we have to actually just rely mostly on news reports. You know, where are people using the term harmful toxic algal bloom, and does that end up either in social media or in a newspaper? We have some scientific databases, we have some satellites that can see if the water's green, but you know, it's really that sort of eyes on the water that we're seeing. So again, this slide shows that between 2010 and 2020, we've drastically increased the number of reports of algal blooms in inland waters in the United States. And you can see a pretty strong clustering of those, Michigan, Ohio, New York. Other states are a little bit more vigilant about looking for them. They have some better guidance on surveillance programs. So you might see some of that come through, but every state in the country has harmful algal bloom problems. So I think if anyone is drawing surface water from rivers, reservoirs, lakes, you should definitely have knowledge of harmful algal blooms. Just to sort of jump back to, this is actually from 2017, and it shows how massive the harmful algal bloom can get on Lake Erie. I think in Lake Erie, it's sort of blooms of epic proportions here. I've also dotted approximately where the water intakes are. So depending on where the bloom is at, we could be getting drawing of water into the water intakes. And it, historically had been that water had to come all the way into the plant and had to be sort of monitored by the chemists on shift and understanding sometimes with the day's lag what the algal toxin concentrations were either the day before or the week before or even the morning before for the afternoon shift or something. So I think we've really sort of seen how we need to change, increase the frequency of understanding the dynamics of surface water withdrawals. Tiny historical perspective, it's not like Toledo gets a terrible bloom every year. So this sort of variability holds true in almost every system that has a bloom that I've seen. Some years it's nearly absent. In some years it's just larger than anything anyone has ever seen. And it's really this, end of the food chain issue of phosphorus, temperature, weather that really lead to either very favorable conditions or mildly favorable as well. So this again just kind of leads to my next slide here, which is know your source water. So and the thing to know here is if it's been detected in the past, that doesn't mean that you're going to see it every year or you're not going to see it. So most of the surface water withdrawals, at least for sure in Ohio, all have some type of a surveillance program in place that's going to help monitor at some frequency that's appropriate for the historical prevalence and toxin concentrations. So again, I think the ones that are in Western Lake Erie are going to always trigger some of those higher surveillance ones, and the ones that are still on the same water body but further to the east might trigger a different frequency. And this problem here, it's not unique to Ohio. We've supported water treatment plants as far away as California with these same issues. I do want to just step back for a moment to sort of the human element to this. I think we heard about some of the cyber infrastructure aspects. We all have cell phones and computers ourselves, and we kind of know that the space in which this resides. When we get to algal blooms, it turns the water green. It's people see it wash up on beaches, and I think once people connect, that green water is also going to the water treatment plant and it's also flowing through the distribution system, they get a real sort of visceral connection to the lake and the conditions, and then sort of what's coming out of the tap. And one thing we've seen is that information, just understanding, communicating to the public that the water treatment plant knows the water is green or knows that levels are, or it's not green, is really helps with that transparency and confidence. So it's really the sort of helping to sort of show the public that this is the condition of the public water body or the lake that we're drawing water from. So it's helped from a public relations standpoint to be able to monitor that lake and share that data with researchers, the public, and also use it in an operational mode for the plant. It's not really operation data, so to say. It's kind of outside the wall, the firewall, the Scada systems. These are just floating buoys. Sometimes we do bring this, I say this on into this greenhouse, but we're generally disconnected from Scada systems in some places, or have a way to sort of throw the data over to a isolated endpoint. So just the sequence of events. What I'm trying to lead up to here is, what is the hour-to-hour thought of people in the facility, and what data streams are they looking at? So previously, NOAA could only see the bloom when it wasn't cloudy. The satellites could see it. So between July 31st and August 3rd, we went from the mild bloom to the massive bloom we saw on August 3rd with a festering surface scum that just sat for an additional 10 days. And if it's cloudy, we couldn't get a picture of this. We had to sort of send boats out to collect water samples, which for water plants, it's really difficult for a person to, a chemist to sort of leave the facility. It gets logistically challenging to sort of send eyes out. So I think the sensors have helped sort of bridge that staffing side and just kind of keep that continuous look. And, if you did have eyes on the water, this is what you'd see. So I think even something as basic as a web camera, what does it look like? It's a big help for the folks at the plant. And of course, the do not drink. If, when we worked with the city of Toledo, it was just trying to understand what are the opportune points for monitoring. When we sort of say raw water, there's various points in here that either we're getting some pre-treatment happening, and where can we start assessing the condition of the transition of quote lake water to raw water, source water, lake water to raw water to, it's sort of in the system now. And we sort of chose to install water quality sondes that are measuring turbidity, conductivity, temperature, chlorophyll, and phycocyanin, which is the blue-green pigment. Chose to monitor it on a buoy just outside the water intake crib on a sensor that's located in the sort of well of the intake crib, and then another sensor at the pump station, which can be there year-round. The two on the lake are only there seasonally, and then there's one that can stay year-round at the pump station. So we get these kind of 3 points of monitoring. One is the buoy is measuring the surface, the intake crib is measuring some mixed volume that's sort of going into the tunnel, and then the low service pump station is a really well mixed sample, very representative of the quality of water that's coming to the plant. And we see pretty big variations between monitoring the surface, where the bloom tends to fester and look the worst, versus what can get well mixed and sort of sent down that intake tunnel and is a really good whole water representation. And this is where science has a really tough time with this answer of, what will the quality of water be coming into a intake structure that's got kind of a complex interaction with its source water. We can't quite pick a sample point for to lower a water bottle down, so it's kind of tough for scientists to even monitor some of the type of water coming in without actually being at the facility itself. And I will say this has been a really great opportunity to point out that sort of very unique access point that water treatment plant intake locations have for monitoring and understanding the lake. I think that structure and some of the basic infrastructure we can't reproduce in the science space. So researchers just can't get access. So I think this project and program here has really helped to bring that science interest right into the plan and have a permanent expertise on understanding conditions. So before we jump to the some of the nuts and bolts, I just wanted to stop and do poll question 1.
Okay, and this first question is, what parameter are you most familiar with? Select one out of pH, turbidity, conductivity, or chlorophyll. We almost have everyone, so I'll give it like 20 more seconds and close the poll. Okay, so for that first one, it looks like 94% of people who answered are most familiar with pH, followed by 6% most familiar with turbidity.
Okay, great. And just remind me of our end time here before we jump to questions, about another 20 minutes. Is that right?
Yep.
Okay. So just jumping into the sort of utility of these sensors, I think it sort of made the case for why they're necessary, but just getting down to the you know, what it's like to draw in toxic water and understand how to you know, treat it. You know, our constant, and this is not going to be a complete look at this. There's certainly a lot of factors that go into the some of the chlorination or dechlorination and the other parts of treatment, but it's kind of putting this toxin data at the center here. So this is, if we go to 2014 and we look at when the city was required to start monitoring after the Toledo water crisis, we can see these dots are the actually represent. I think this is my left axis here is off. So this is the raw microcystin data. So this is from the ELISA kit test, and they would get one sample a day. So you would collect it in the morning. By the time you run it, it'd be early afternoon by the time you'd understand what the toxin levels were. So we can kind of see the you know, extreme variability in these numbers from one to the next, especially right during the worst parts of the bloom where we're going to 2. This is micrograms per liter and jumping up to 14, 18, and then back down again. This is if I take the, you know, we installed the water quality sensors the week after the crisis. So just, you know, this is the actual 8th. So 5 days afterward, we're able to get a real-time optical sensor out there that's measuring the phycocyanin, which is the blue-green color of the water. What I'm showing here is the daily average of that RFU value, which is mapped on the left here. So again, we can see that the SON data shown in red tracks pretty well to the signal seen in the microcystin data. And so this really helped validate that you know, if we collect a toxin measurement, we can kind of get used to the ratio of microcystin to this RFU phycocyanin. So if we can kind of see that at the SOND, which is taking a measurement, you know, optical measurement every 10 minutes and sending it to the internet, that those operators can see that and know that either toxin levels are probably going to go up or they're probably going to go down. So it just helps mitigate the risk. So that was 2014. I wanted to show some other data from other years. You know, we were able to install that last one is actually from the buoy. We installed SONs in the pump station as well, and we get a really, I'd say, pretty stable signal. Again, this is showing the daily microcystin data from ELISA in the dots and the daily average RFU value for the SOND itself. So again, we're able to really track the start of the bloom, the rise in toxin concentrations, and the fall kind of back down to 0 after the summer is over. And 2016 was a little bit of an anomaly, but I'll show you just a little bit of a sequence. There's still a ton of usable data. I'm showing the daily average result here. There are spikes in some of these days, which is indicative of, you know, the SOND is definitely picking up some increase in algae, but it wasn't matching this sort of 1-to-1 ratio. So I think we're always looking for signals in water treatment. This is, if we jump to 2015, and this is looking at the pump station data here. And again, I'm sort of showing the lab microcystin data in the dots and the daily average of the SOND reading in red. But this time I'm also going to show the standard deviation throughout the day. So if it's a really noisy signal that day, it'll be wide standard deviation bars. So on this day, leading right up to July 29th in 2015, we can see that the SOND daily average was pretty stable, but then all of a sudden on this day we get a you know, a real noisy day. So the RFU values are jumping all over the place in the morning, and then by the time they get and run the ELISA sample, we see that a microcystin jump from that sort of non-detect up to 1. So I think the SON was able to detect that there's a lot of green stuff or blue-green stuff in the water, which is kind of that initiation. the sonde calmed down a little bit, and sort of the microsystem data. When we had another day of really sort of noisy RFU values, again, we saw another jump in that measured microsystem toxin. So when people ever ask me what RFU value is bad, you can't really give that answer. You really got to watch those signals and look for what is changing dramatically over a several hour period. When do you start getting a ton of noise in your seemingly stable signals? And this just tends to get worse here in August. We can kind of see the bloom sort of came and went a few times in early August, but now we're sort of getting into that sustained bloom period, really noisy RFU values and rising microsystem levels. Toledo had these different levels of switching to their watch statuses, so we're sort of rising into the peaks of the bloom. I kind of wanted to jump out to the full year to kind of give you what 2015 looked like. And again, it's not a perfect matchup here, but you're looking at how noisy is the signals, is the bloom present? And as you get into the fall, you definitely get a sense of it's getting better. Few days are rising a little bit above 1, and now we're in the difference between 1 or 1.5 micrograms per liter. So I think in terms of treatment, it's important if we know we got to double or triple that carbon rate. So this can help give some indication to that concentration doubling or tripling. Yep, and just kind of another summary of that. I just wanted to break it again into these three phases. That sort of pre-bloom condition where you're watching, almost every one of these measurements, and has the bloom started? Do we see it for a day and is it gone, or are we in this sort of sustained bloom condition in the middle where every day, all day, we're going to be drawing in pretty higher toxin water, and then we kind of get into this, when do we sort of start ramping down some of these carbon treatments? So I think it's really trying to optimize these windows of being nimble and agile with some of the treatment levels, and you can imagine the sort of confidence of operators once they start understanding the longer term trends that they're dealing with, and ordering inventories, or is stuff working at its tip top shape. So I think you can kind of really narrow your effort. You kind of get to this fatigue in this HAB season when you're treating toxic water all day, every day. So if we can narrow that window that everyone's sort of all hands on deck, I think it's been really helpful. I also wanted to show for the city of Oregon, this is now, instead of the daily average and standard deviation, I was just going to show sort of every 10-minute measurement, and this gives you a little bit of an idea of that raw signal coming in. You kind of see what I mean by how noisy it gets. So again, in 2015, hardly any sort of noise in that RFU data, low numbers, maybe just above detection here early that we can kind of see, and then quite a bit of corroboration of the toxin data with the sonde data. So we see this pattern consistently, and one thing that's been really tough for these surveillance programs that have such infrequent measures of microcystin, it's really tough to build the confidence in the performance of this. If anyone's noticed, the X or the Y axis on this has been dynamic every year. So we know that the bloom isn't gonna show a repeated ratio of RFU to microcystin. So we almost always have to be understanding that the actual toxin concentration and that response to the sonde, if we're gonna start relying on the sonde in some near real-time mode. We could certainly think about some threshold triggers for that RFU data. Anything you start getting above 1 starts getting important, but again, not all blooms are toxic, so we could be seeing a rise in this RFU, but not necessarily a rise in toxins. So anyway, I'm just trying to watch out for some universal applications to places that don't have a lot of data. In 2015, we did work with almost every water treatment plant on Lake Erie to get the same technology installed. I think some of that, what we walked through is some of the same slides I showed over and over again at meetings, like this and others, and just trying to think about how to get into the mind of that operator and what decisions they're making when, and how that source water is changing. Looking out further up the pipe out to the lake and being able to monitor that. One thing that became apparent is all this technology, all these sensors, all these sondes, they're all online, they're all streaming data, and is it actually accurate? Are these sensors behaving? Is it quality data? So we've implemented some QA, QC programs, and I think this is part of the impetus for this presentation, is really understanding when we're all sort of either drawing from the same water body or we're all drawing from water bodies that we know are going to have harmful algal blooms. I think understanding how these mostly research sensors are able to provide valuable insight for operators. And we sort of worked with the University of Toledo and are able to assemble all of these sondes once a year. This is what we call our spring calibration event. And we just held it a few weeks ago, and we had almost 40 different water quality sondes there. I'd say about a little less than half were from the research community, and the other half are sort of dedicated to the water treatment plant, pump stations or buoys. So it's been nice to kind of have this seamless technology connection from monitoring the pump station signal of this harmful algal bloom to measuring the same signal out on the lake and water body that researchers will do in other locations. So again, for folks that draw surface water, knowing how there may be a bloom upstream, or if there's a bloom near the water intake, we can understand that and kind of use the same sensors. Some of the same parameters are monitored by water chemists at the facility, so the turbidity and the pHs. Chlorophyll is maybe a little less common. I know some folks rely on just looking at a microscope and just trying to, at a glance, see what the algae look like. I think the advancement of technology is, far enough. These are relatively, these sondes are expensive because they come from the research side, but it's a relatively inexpensive LED light that's just flashing a particular wavelength, and then it's reflecting and reading that how much energy is coming back with that wavelength. So, sort of the optical measurement technology. And we've seen this, there's all kinds of things that we're being able to measure with the precision of LED, that wavelength, and the detector. So I think we're going to see more optical sensors emerging on the market. One thing that these sensors don't do is get into some of the algal species classification. There's a lot that we can still monitor with identifying potentially toxic algae, understanding how microcystin may be lysed, or the cells may be lysed and broken open. There's sensors now that are still in the research phase that can monitor for the lysing of cells and how much of that microcystin is intercellular inside or extracellular outside the cell, which has implications for water treatment. I did want to just kind of highlight a research project here as well. So, we've been talking about concentrations in water treatment, but it really wasn't until just a couple years ago that we were actually able to take enough grab samples that we could estimate the total mass of microcystin in Lake Erie, and it was about 30,000 kilograms of toxic, microcystin toxin, which, I didn't do that calculation. It's got to be like every elephant on Earth could be killed with this amount of microcystin toxin. It's just this stuff is extremely lethal. Now it's diluted in a ton of water here, but again, it's just a good exercise to see that Mother Nature can produce quite a huge volume of these toxins and just have them sit out there. Moving on to poll question 2 here.
Hey, so where does your facility draw its source water from? And the options are Lake Erie, a river, reservoir, or groundwater.
And Ed, I'd also like to note, we've got plenty of time left for this presentation. The question and answer, kind of the end time will be about 2:17, so we've got plenty of time to get through everything.
Okay, thanks.
Okay, and it looks like we have everybody's answers in. So, sorry, I have to rearrange my screen to see these. Okay, so Lake Erie is 59% of the answers, followed by groundwater at 18%, and then river and reservoir each have 12% of the answers.
Great, thanks. So I'm preaching to the choir here about about Lake Erie. So that's kind of the basics of, I'd say, why we have those sensors, what signal they're monitoring. I wanted to step back just a moment to some of the technology side, and for folks that attend any water treatment plant conferences, sort of trade shows, you know, you're going to see a ton of vendors focus on the in-plant pumps and optimization. Lots of care and attention to that. You know, the inside the facility is such a dense technological space. You know, my brother works at Wayfair doing control systems for warehouses. And again, just a highly automated, dense technology space. The sort of dollars for the equipment kind of falls away in regards to how much is at stake in terms of you know, people's salaries or the value of the sort of product that's going out. Well, when we get to monitoring the natural environment of the source water, you know, we lose sight a lot of those that density issue. You know, how do we get enough sensors out in the water body or far enough upstream? We start venturing into jurisdictionally difficult monitoring scenarios where you don't own the water body. If it's a reservoir, I think that's a unique scenario where you have a little bit more of a absolute control of monitoring and understanding what's in the reservoir. But you know, we're generally into this mixed space, and this is kind of where the emerging sensor and tech development, how do we assemble those that same type of tech density that we have inside the facility? How do we start thinking about that infrastructure that's feeding data in? So, you know, well, we have physical water coming in, we also have other physical data streams that can go along with that to understand, you know, the conditions, trends, and changes. This graphic here really starts to expose some of the decisions that we make, and for folks that are in any of the internals of facilities or talking about some infrastructure, kind of probably understand these a lot more than I do with that industrial angle. But you know, I think when we're thinking about lakes and rivers, we generally think about scientists on a boat. So they're sort of being exposed to these different categories here, from picking the right sensor to how does that data get sort of sensed first. You know, is it an analog measurement, digital? Is this a RS 232, 485 sort of strings that we're reading? Are we averaging something? Are we taking bursts? Thinking about how that data actually gets transmitted from a remote site to, let's say, a decision support system. And what's not shown here, which we saw a little bit before, was how those sort of data packets or information can cross into that operator space to be able to see the buoy data. And we generally just use a plain old website for that right now. We do a little bit of a direct connection to some Scada, you know, isolated IP connection to some of these instruments to be able to share a data packet reading that's going into a Scada and alarm system notification versus going out and being posted to a public website, so to say. And the platforms, again, I sort of mentioned the water infrastructure, buildings, pump stations, intakes are a first logical point to put sensors. But if we want to get further upstream or away from that, we're into buoys or other piers or even other boats. And I won't go too much more on the right-hand side, but I think for the end user here, we're most interested in the operator and the operator, superintendents, and even the mayor. We've had in the city of Toledo, the mayor would get a daily report of the RFU values because that would happen first thing in the morning. You'd be able to see what the sign says. Is this going to be a bad day? And just that data delivery, I've sort of seen operators use these public websites when they're not on shift. They kind of like to see, what are they going to get into? What's the lake looking like? So so again, I just sort of seen that data delivery change a little bit as the value of that data goes up and people really want to get access to it. Again, just kind of keep stepping back to that sensor of this lake space. This is an actual map of all of the sensors in 2019 that were deployed in Lake Erie. So it's a heavily instrumented lake, one of the most instrumented on all of the Great Lakes. I'm actually at a week-long Great Lakes research conference right now in Grand Rapids, and it's just incredible the amount of monitoring that we do of the Great Lakes. But one thing to note, the yellow dots and the red triangles, none of those are real time. So those are all self-logging. The data from those is just the fish tag data. So all the tagged fish in Lake Erie are tracked through a logging of a receiver tag to those yellow dots. And then those yellow dots are retrieved once a year and downloaded. So what stations are real-time monitoring for algae? It's just the green dots along the shoreline. There's a few buoys in the western side of Lake Erie. Some of those blue dots are measuring chlorophyll as well. So we get down to, there's really not many that can give us this real-time look. So I think we still have a long way to go to try and get every one of if every one of those dots was able to measure chlorophyll, we'd have a much different picture of where the bloom is at and how intense it is. Just to go back to this sort of technology sort of specification problem, we sort of had to, I guess, self-specify these components in the week after the Toledo water crisis. So we generally grab the scientific versions of these. These loggers come from a scientific-based manufacturer. They have some Scada capabilities, but so I think the wastewater and water sector has the opportunity to spec equipment that they'd like to see put out in this water space. There's a lot of technologies, including the 900 megahertz systems. How do we extend the power of that utility data collection system that may be focused internally? A lot of those elements, if we just focus them externally or start pointing some sensor gateways offshore, we can help to bridge this gap we have between the research community and the sort of tightly controlled Scada infrastructure that's internal to the plant. I already showed the buoy a little bit, but this is generally the floating laboratory that we have out there. It's measuring water currents. We have a web camera on it, air temperatures, wind speeds, wave heights, water temperatures. The YSI is housed in a PVC tube here that just sits just below the surface. And we also have, again, as I said, equipment installed at the water intake crib and the pump station. We sort of, I would say these are, hacked in sensors. We generally, because of the time frames, didn't sort of go through a lot of the same contractor protocols to get, installation pipes or, special trades in for clamps. We just really had to dangle it from a rope down in there. And we've come back and fortified the installations and made things a little bit more permanent. But I think it's just coming from a little bit different specification space. So if anyone ever has any questions about how to spec these or how to get them into a capital project, it's been really challenging to make sure some capital programs can sort of cater to the environmental sensor space. City of Toledo has done a really great job of outfitting their crib building actually to accommodate between power, space, and we're also even working on some data isolation and capability to use some broadband at the site. So I think it's helpful when we can at least start to think about that infrastructure to support a science base or access into our facilities. One thing I always want to point out is we're trying to make these buoys a lot smaller. So trying to get, this is buoys we made last year. This is in Chicago. So we're able to kind of break these buoys in parts, make them about half the size that we have previously, and just fit them on the deck of a small towboat. So we can just throw the foam float over in the water, and we can just drop in all the electronics right into the middle. So we're kind of thinking about that operation and maintenance budget. These things get expensive to maintain. So it's great to be able to think about the sort of maintenance costs and how to make it easier to service. We just deployed a new buoy this year on the Detroit River. This is looking towards the Ambassador Bridge. So the Detroit water intake is actually located in Canadian waters, right in the middle of the Detroit River. So we kind of had to stick a buoy out in Canadian waters to watch for water coming down Lake St. Clair. So, you know, what does water look like as it's coming off that broad, wide open parts of Lake St. Clair, and is there any concern for an algal bloom heading towards the Detroit water intake? This is that other buoy sort of fully assembled off in Chicago. So I think we're starting to see this sort of gold standard, and it really started in Toledo with the water crisis of why aren't we monitoring surface waters continuously near water intakes? And this has only been as the gold standard of water treatment changes, just like we might think ozone might be the standard for some water treatment, sort of having a monitoring station near water intakes is starting to become the gold standard. I'm a little biased because we certainly support getting them all out. We've been working in Cleveland as well. This is a picture of our boat here near the Cleveland water intake crib. So again, just starting to like think about, to me, it's starting to seem more like common sense that we have more sensors out on the water bodies that are continuously sending water into facilities. Before we get too close here right to the end, let's just jump to poll question number 3.
All right, so what lakes are most likely to have a bloom present? You should select one, and we have either shallow, deep, a river impoundment, or all of the above. Like 1 or 2 more still might need to answer, so we'll give it about 15 more seconds. All right, and we have everyone, so let's see what we got here. Okay, so 53% said shallow lakes, 6% said deep lakes, and 41% answered all of the above. We had none for a river impoundment.
Okay, yeah, I think that was maybe a trick question. I think if you think about most, it's probably shallow lakes, but you know, certainly all of those locations can have pretty toxic algal blooms. Lake Superior recently has had quite a few algal blooms along the shoreline. You know, you think about those tributaries that are dumping water, and the water hugs the shoreline. You know, we can't assume that a river discharge goes out and instantly mixes across the lake. So I think that near shore zone, which is often where we cite water intakes, can be a prime spot for algal blooms. So jumping into the last few components here, I'd kind of wanted to mention, I think the water treatment plant folks are not alone in wanting to understand conditions on rivers, lakes, streams, and reservoirs. And so I've always asked people to connect to other users in the region. This not only helps with research connections. If there's something weird about the water, you'll be able to have an expert nearby, and you might even interest them in monitoring something at your water intake that would help them understand this phenomenon that maybe occurs elsewhere, but is good to use as another point of monitoring. So we've worked with nuclear power plants, water intakes, potential wind energy projects to kind of use the same technology and really use that, wherever we start putting dollar values on water is opportunities to reinforce the support systems for monitoring. I think research tends to move so much with what's the hot topic of the day, and researchers really struggle with any continuity of the same sensors measuring water bodies consistently, especially near water intakes. So I don't think we can keep relying on researchers alone to try and attract grants or public dollars. I think it's sort of a shared responsibility with using that water facility intake as a nice anchor for the investment in monitoring and working with researchers as they either have some new sensors or some new grants. This is one example of that here. This is off of Cleveland. We sort of have the big buoy monitoring near the water intake, and then we were able to work with an Ohio-based company to get a baby buoy here on the right-hand side. So this small buoy, it's just doing waves right now, but they have the ability to add some water quality sensors to that. There's a lot of limits of technology we start to push when we think about cost and size. The equipment on the left there is about $70,000. The buoy on the right is about $10,000, but it doesn't have any water quality. We could add water quality from definitely less than 5,000. So we could almost have a 1/3 the cost buoy if we just thought about the specifications a little bit. What does it need to monitor, and how easy it is to deploy and retrieve? You can imagine the one on the left takes a crew of a couple trained people to know how to deal with that platform, versus just maybe a water plant operator could just, or a chemist could just run out and throw the buoy in on a charter boat with that smaller buoy. So just trying to think about like a 10-year plan and how we can use technology. This is kind of where we've led to the founding of a new company. This is a really interesting intersection of these research sensors with some operational space and maintenance considerations. And I think, again, walking that trade show floor at a WEF conference or something, or an AWWA, you don't really get exposure to the source water sensors or what's involved in measuring that space. So again, this research technology, I just wanted to show, we've seen a ton of pictures of Lake Erie. I just wanted to show a beautiful picture of Crater Lake, Oregon, where based on our experience installing the same equipment in Lake Erie, we were able to replace the National Park Service's buoy that has been monitoring Crater Lake for about 30 years. So it's just kind of neat to be able to transfer that tech to another large lake and not have to involve the large oceanographic vessels that generally work with this larger tech on the West Coast. So I think that's all I generally had here. We can jump to poll question 4 and see if I had any slides left.
All right, so what is more toxic per gram? Cyanide, DDT, PCB, or algal toxins? All right, we have everyone's answers in. Okay, so 76% said algal toxins, followed by 24% for cyanide.
Yeah, that's great. Algal toxins are definitely the most toxic per gram. There's a tiny bit of a nuance when you get into what algal toxin is it, and then it even gets a more complex answer of you know, the sort of dosage and how much the person weighs and stuff. But yeah, it was surprising to me, this sort of, you know, we're into the micrograms per liter, and these chemicals tend to persist too. You know, they can there is a little bit of a natural degradation, but it's just, you know, hard to believe that sort of these innocuous algae can produce such a toxic compound. Oh, I just have one more point about, you know, we talked a lot about algal toxins. There's a lot of other environmental source water phenomenon that science and sensors can help monitor. This is a installation of online nutrient analyzers that are measuring phosphorus, nitrate, and ammonia at the City of Defiance's pump station on the Maumee River. So, you know, they've traditionally had to just use some hot kits to sort of get a shoot from the hip estimate of that ammonia and understand, should they pump from the reservoir today or pump to the reservoir today or not. I think we've been able to kind of, again, take that research sensor and how does it live and operate within a sort of 24/7 production facility. So I think, again, the better we can get at it, the better that operators can try and get over some of these frustrations with either what equipment's available and how that data and decision gets made, and can we lower that risk factor. So, you know, we're able to just quickly grab a manufacturer on the East Coast, install this equipment, the sort of data. This is just a web data dashboard showing some streaming data from the sensors. You know, the cost of this dashboard to maintain from this one company that we work with is only $1 a month. So there's you know, tons of flexibility we're getting in terms of how to quickly get data into a system. This doesn't address the Scada or any security questions. We've sort of treated these as a externally connected cell system that doesn't interact with the Scada and Defiance, but it's again, just ways to get sensors in quickly and have that sort of public websites be a delivery of source water data. So just a little peek into the mechanics here. Again, these are sort of laboratory instruments we're able to run operationally. If anyone's interested, since everyone is sort of from the region, there's going to be a showing of a documentary film that I sort of helped with. I'm interviewed in it talking about the sensors that we talked about today. It's going to be showing on Sunday, June 12th at the Maumee Indoor Theater at 5:30. This is a free and open event, so if anyone wants to take their families or kids and sort of show them some of the science of the algal blooms, it's an interesting look into that issue, and sort of has the water treatment as one of the main groups being impacted by it. And that was it. So again, thank you everyone. I appreciate your time and attention, and hopefully everyone learned something today.
Yeah, and thanks, Ed. Really appreciate you coming out to be able to present this great information to us. I know one of the questions I have is, I guess, what would be, if you could add something to your sensor buoys, what would kind of be, you know, the dream item that you'd like to add into those sensors?
You know, I think part of the dream, there's some advancements into the, you know, we can also measure dissolved organic matter, so the FDOM. So it's really, you know, what are the, you know, when we get into the water treatment side, yes, we can add carbon to remove the toxins, but there's a lot that affects the efficacy of that carbon, for example. So I'd want to just fill out that parameter suite a little bit more, and also try and understand that, are the cells lysing or not? The technology's there, we just haven't had the sort of, I guess, group specification to say, you know, we need all these sensors to be together at the water intake. And we generally rely on, I'd say, the largest users to start that. And then maybe the other side, this is just a personal thing for sensing itself, is trying to use these Internet of Things sensors to get out into that distribution system and really help use some of the best use of this monitoring tech is when we increase the number of sensors. So you know, if we can get, our turbidity sensors are expensive because we make them in such low volumes. If there was an interest in, you know, hey, it'd be great to have like a turbidity sensor on every fire hydrant, we can do that. And the cost would go down dramatically with some group purchase power. So I think that's maybe another wish list item, is to help use the power of sensing what we might want in the distribution system, but then also makes it a little bit more ubiquitous to put those out on the water systems as well.
Great, thanks. Another question I have is, what do you see the role of kind of, say, citizen science, or, you know, there's a lot of new developing technologies for like rapid detection of microcystin by, you know, smaller units through like beach managers and like charter boat captains and those kinds of organizations. How do you see that fitting into this overall sensing ecosystem?
Yeah, I think similar to that, the graphics and how you sort of treat the internal IT infrastructure, we need to start having some you know, delineation between reputable data sources and how data can cross over that. So, you know, from citizen science data, we can't totally ignore it, you know, despite some maybe quality concerns. So I think it's really understanding, you know, the mechanisms for evaluating that. And it might just be, you know, you're not going to make a treatment decision based off of a citizen report, but you might call the local university and get a verification. So or you might go collect a water sample. So it's really figuring out what does it mean and how does this data interact. I think the future, just to step out to the future, the sort of sensing space I'm talking about, I mean, generally assumes the facilities are helping to control the sensors going either out into the lake or in the distribution center, and that's not going to happen. I mean, we're going to see sensors come into people's house. I mean, everybody's sink is probably going to have a online turbidity sensor on it, reporting to their app that's going to, you know, Jeff Bezos or Mark Zuckerberg's computer system first, and you're going to have to buy the data to get it back. So I mean, these sort of data pathways, they're already set up. So I only see these sensors getting attached to everybody's water bottles and drinking fountains, and you know, there's all kinds of stuff already starting, and you kind of see how what stuff gets, I'd say, you know, mass produced out of China. Once we sort of get to the scale that we're talking about, the price drops and these things suddenly end up in every Best Buy and Meijer, just like backyard weather stations. You kind of think about the backyard weather station model. It was generally only accessible to professionals, but it's, you know, almost every hardware garden store now has a weather station that can stream data to the internet. So I think the water data is not too far behind some of those same interests. And it's really the value proposition. What, you know, water is a valuable resource. So I think we're going to keep seeing people interested in what is it doing and where is it moving.
Do you think it would be helpful to include these kinds of sensors in the distribution system as well? So kind of in the, what you could say for the drinking water side, you know, those water pipes within municipalities, you know, is there any thought to be able to add in things at that small scale level? Or, you know, again, is this still really out on the broad side?
Well, it kind of goes towards that signal monitoring. So, you know, I talked about, let's monitor the signal of the harmful algal bloom. If you look at that sort of same sensor diagram, you know, one thing Toledo had, or, you know, gets into the lead issues too, of how long does water sit in distribution system? What's the quality of that water? Has there been a pipe break and the turbidity is changing? You know, do you want to just rely on people's reports giving you a call saying, hey, my tap is dirty? Or can you just already know that? You already have the, you know, and I'm sure the sensors will be able to even detect those, you know, lower turbidity. People have a tough time seeing some of the different turbidity levels and knowing if it's a problem. So I think the sensors, again, just being able to provide that source of truth and using some opportunity monitoring points throughout the system to do that. There's a lot, a lot of those trade shows are starting to show these sort of fandangled stuff, and I think a lot of the accessibility of it is already here with the plants themselves. If you're, you can wait till a proprietary company comes out with something, but just know it's generally available today.
Great. Well, thank you so much for doing this event today and providing some great information. I know we're right at that time of year where we'll start seeing how things are going to be developing over the season, and hopefully we'll continue to be lucky and things won't be too crazy, but really appreciate all the work that you've done.
Great, thank you.
All right, thank you everyone for attending this event today. Just wanted to provide a quick wrap up to make sure that we can get contact hours for everyone who is applying for those today. What I'd like to say is that, again, the contact hour request form can be found and downloaded from the handouts section of the GoToWebinar panel. And we'd please fill out these forms and return them to TMACOG by midnight tonight. Those will be on the information provided in the follow-up email will also go to Ann Nair, the Water Quality Administrative Assistant. We'll provide all these contact hours to everyone who met the minimum requirements for participation that I'd outlined at the beginning of the webinar. I'll notify everyone of those contact hours via email, and you'll be provided with a certificate of attendance to reflect that. TMACOG will then go through and upload the qualified attendees to the OEPA website within 30 days. And I'd also like to remind everyone that at the end of the survey, or at the end of the webinar, there's a mandatory survey. So please let us know how we did today and how we can do better next time. Thank you everyone for attending this event. I'll also advertise where we have another one coming up on Thursday that is more focused on wastewater topics, but you can actually still register for that if you hadn't registered yet. You can still go through and get access to be able to be a part of that webinar, and it's the same process that we went through to sign up for this one. I've provided some of the contact information for both myself and Nair. And then also when you go to fill out your contact forms, which I'm sure as everyone knows, you got the information associated with the approval number and the course credits. Now, as I'd mentioned previously, there will be an email that'll go out about an hour after the end of the webinar that'll also have the presenter information as well, so that you can get those forms filled out. And again, if you have any questions or any concerns, feel free to email me. And just thank you again to everyone for joining this webinar today. And with that, that concludes our session, and I appreciate everyone coming by. Thank you.